Hello students, today we'll be discussing about the concept of vapor absorption refrigeration system. First, let's discuss about the simple vapor absorption refrigeration system. In case of VARS, we are replacing the compressor by one generator, one absorber, one pump, and a pressure reducing valve. Unlike VCRS, here we are using a low-grade thermal energy system. Here at the generator, the waste steam from the plant or any solar energy can be used. Here in this case, we are using one pump which has very significant less mechanical work. So let's discuss about the working of simple VARS system. As we know that in case of VCRA, we have one condenser, one expansion valve, one evaporator, and one compressor. In case of compressor, we are using generator, pressure reducing valve, liquid pump, absorber here in case of VARS system. Here the refrigerant used as ammonia and in the absorber, the absorbent used as water. As water has high affinity towards the ammonia. At the evaporator, the refrigerant will absorb the latent heat and will get evaporated. This vapor refrigerant will get drawn by the absorber. Here the absorbent is present which draws more and more ammonia and a strong solution of aqua ammonia is created. As the water absorbs the ammonia, its pressure drops and more ammonia is drawn from the evaporator. Thus, a strong solution is prepared at the absorber. This strong aqua ammonia solution is then pumped by the liquid pump to the generator. At the generator, here we are providing a low-grade thermal energy to heat the strong solution. As the solution is heated, the refrigerant from the solution will get released from the strong solution and then go to the condenser. From the condenser, it will release the latent heat and through expansion valve, it will again go to the evaporator to absorb the latent. Here at the generator, as the vapor ammonia has released, a weak solution is left at the generator. This weak solution is then comes to the absorber again through the pressure reducing valve. As the pressure already increased through the liquid pump, here we are using a pressure reducing valve here. As drop in pressure has high tendency to draw vapor ammonia from the evaporator. So this is how the simple BR system works. For practical case, we are using one analyzer, one rectifier, and two heat exchangers here. This analyzer and rectifier function is to remove any moisture present in the ammonia vapor which is leaving from the generator. As the moisture present in the vapor refrigerant will, if it will come to the expansion valve, it will choke the expansion valve during the expansion process. So next comes to the function of the analyzer. The analyzer will be mounted on the top of the generator and it has series of trays. The strong solution through the pump will then supply to the top of the analyzer. This strong solution will then come to the generator by passing through number of trays. Here at the generator, we are providing low-grade thermal energy. That means the ammonia along with some moisture will then get evaporated. When this moisture which is present in the refrigerant will come in contact with the low temperature strong solution which is coming from the analyzer, then the moisture present will get condensed and then comes to the generator. Here the refrigerant leaving the analyzer has 99% of vapor refrigerant and there is also 1% chance is that 1% of moisture is present in there also. So this 1% moisture is removed to the rectifier. The rectifier here, the cooling arrangement is done when the vapor refrigerant with 1% of moisture passed in contact with the cooling water. The moisture present in the vapor refrigerant will get condensed and then will come to the analyzer. The refrigerant leaving the rectifier has 100% pure vapor refrigerant. Then let's know about the function of the two heat exchangers. One heat exchanger is placed in between the condenser and evaporator. From the condenser, high temperature, high pressure liquid refrigerant is coming. And from the evaporator, low pressure, low temperature vapor refrigerant is leaving. Here, if we provide one heat exchanger here, the result will be subcooling of the liquid refrigerant coming from the condenser. And it will release its heat, the low temperature, low pressure vapor refrigerant, leaving the evaporator. And we also know that subcooling increases the refrigerating effect and the COP of the system. There is another heat exchanger which is provided between the pump and generator. With the help of pump, we are supplying the low temperature strong solution to the generator. And here from the generator, a high temperature weak solution is returning to the absorber. If we provide one heat exchanger here, heat is exchanged between these two solutions. With this act, the strong solution will get heated and the weak solution will get cooled down a little. As it is heated here, less amount of heat will be required at the generator. And as it is cooled down a little bit here because of the heat exchanging, the energy supplied for cooling the absorbent here will be less.